Okay, so remember what I told you, that there will be at least one question on the test that has to deal with the difference between the t and the z distribution. If you need more help with it, I suggest that you read at least the first couple of pages of chapter 23. Okay, so let's see what problem number 1 says. It says, which correctly compares the two? Okay, so both are unimodal and symmetric, so number 1 is good. Number 1 is good. Come on, make that right. T distributions have least spread. Okay, now when they talk about spread, they're talking about the horizontal axis, and they both have the same amount of spread. So again, that's the horizontal axis. Okay, so that's out. And as degrees of freedom increase, as n increases, the values of t become smaller. And that is true. And remember what I said is that as n increases, that the standard deviations have a tendency to be not vary so much. They be more similar. And so for the only unknown then becomes the mean. And so therefore the t becomes more like the z. So both 1 and 3, so D is the answer. Okay, so let's look at number 2. They want to know here about defining a 95% confidence interval. I'm hoping that you think that this is a no-brainer, all right? So read those through, and E is the most what a confidence interval would be. Okay, let's go to 3. The key things here is HA and N. So if n is 16, that means my degrees of freedom is 15. So it can't be B, and it can't be E. Okay, now look at, I circled HA, which is a greater than sign, so that can't be A. So that means it's either C or D. Now I know it's not C because it says 2 times the probability, which means that's what it is for not equal to. So the answer is D. See how I did that without doing any math? Okay, let's look at number 4 here. I already have this stuff circled. It said 10 customers, so I know the number underneath the square root symbol has to be 10, not 9. 9 is the degrees of freedom. All right, and so I don't think it's going to be A because it says 1.96, and they're hoping that you would get confused and pick that one instead of what it really should be. So I'm in T inverse now on my graphing calculator, and I get 2.22, so the answer is B. Okay, let's go to number 5, and I highlighted more. So we know that HA is going to be mu1, which I guess is what they're interested in, is U2 is greater than 0. Okay, so what is the p-value? The p-value that if HO is 2, what's the probability that HA can happen? Okay, so the only one that comes closest to it is B, because C is that there is no difference. And what is this here? That there's a 22 chance that they get the same results. All right, the deal is that the answer is E, and let me see if I can explain this. The reason is that, remember, it's the probability that the difference between the two. Okay, the difference between the two. All right, and so there's nobody here that talks about the difference between Eric, whatever that word is pronounced, and Manuel. All right, and so that is why the answer is E. Let's go to 6. 6 is a trick question. The principal wants to know the mean number of families in his schools. He checks, and look at what it says, he checks all. So if he checks all, he knows the truth. He knows the truth. Is there any reason to do a confidence interval? And the answer is no. So the answer is B. There is no reason to do an inference. Okay, let's do number 7. And they want to double the sample size. Okay, so what happens if we double the sample size? Remember, where is n? It's in the denominator. Now, we talked briefly about this when we were doing errors. If the denominator gets bigger, what happens to the whole fraction? The whole fraction as a whole. It gets smaller, all right? So what happens then? We would decrease the standard deviation of the sampling model. All right, 8 is a funky number, or a funky problem, all right? So bear with me. If we have alpha is 0.02, so I go look on the t distribution for 0.02, and they said a large number, all right? Where this is a large number, all right? So I'm going to look at all the numbers here for 0.02. And then it says, that's for a one-tailed test, and then it says a two-tailed test. Well, if the total area is 0.02 and it's a two-tailed test, then that means one half is going to be 0.01 and the other half is going to be 0.01. So I'm going to look at 0.01. Now you go look on the t distribution and you go all the way down at the end where n is equal to infinity. Basically, you look at the t distribution, all right? And for what they have for 0.02 is, let me erase this 5 here. They have 2.054, and what they have for 0.01 is 2.326. All right, and so what did they say here? One student did a one-tailed test and rejected the null hypothesis, and then the other failed to reject. All right, so that means the number has to be between 2.05 and 2.32. And which number is between those two numbers is D. Okay, I will probably get asked to do this problem before the test. Typically, that's what I get asked to do that one. Okay, let's do problem number 9. Then they're talking about pooling. So I had to go look this up. Let's go see if this, we'll have to go check to see if it's on our formula chart, okay? But anyway, the formula is n minus 1 times the standard deviation of 1 squared plus n2 minus 1 times the standard deviation of 2 squared, and then n1 plus n2 minus 2, and then you take the square root. Okay, so over here I have the numbers. So you take the square root, all of that, and then you get option D. Okay, let's go to number 10, and they want to know about a type 2 error. And so that is when HA is true, but we go with HO. Okay. So the answer is going to be C, because they aren't real. We decide that they aren't cheaper, but they really are. So that's going to be, so HA is true. Okay, so here they want to know about matched pair designs, and it's pre-test and post-test, okay? This took a while. This was quite a complicated multiple guess. If you have questions, come in for tutoring or Emoto me.